Zener diode is a specially designed PN junction diode which has a sharp breakdown voltage. Zener diode acts as a voltage regulator.
In this model, we will study about Zener diode voltage regulation characteristics.
In this model, we have used Zener diode, potentiometer, resistor, multimeter, voltmeter, connecting wires, battery, and LED bulb. The main principle of this model is that Zener diode is connected in parallel with load to get the reverse biasing, and when the voltage of Zener diode exceeds the breakdown voltage, then we get the constant voltage across the load resistance. The circuit diagram for Zener diode as a voltage regulator is shown here.
We have connected.
In the input, we have used battery and potentiometric arrangement to vary the voltage. With the help of voltmeter, we will calculate the input voltage. In the series, we have connected the series resistance. In the input, we have used battery and potentiometric arrangement to vary the voltage. With the help of voltmeter, we will calculate the input voltage. And in the series, we have connected the resistance Rs and a Zener voltage having a breakdown voltage Vz.
We have connected load resistance in a parallel with the Zener diode across constant output voltage.
Here we use a series resistance because it prevents the Zener diode from being damaged due to excessive power dissipation. And here we use a potentiometer over any other device because it acts as a volume knob. And we know that Zener diode has a certain temperature changes conditions and load conditions. So potentiometer acts very quickly in these conditions.
So now let's see how it works. Here we have a battery of 9 volt. I'm connecting this battery. Also we have a potentiometer which is also known as a variable resistor. You can see as I'm turning this knob on the voltmeter, the voltage changes. This is how the potentiometer works. It works to give us our input variable voltage. Also we have connected a Zener in parallel to the load resistance. So it works to give us a constant output voltage. Also you can see from the glowing of a LED bulb, as it glows constantly, it means our output voltage is constant.
When we connect the terminals of multimeter with the diode ends, we get a constant output voltage across the multimeter.
That is 0.3.
Connect the terminals of multimeter with the diode ends. We get a constant output voltage across the multimeter. Connect the terminals of multimeter with the diode ends. We get a constant output voltage across the multimeter. The value is 3.0.
Here we plotted the graph between the input and output voltage. The graph shows that the output voltage increases linearly and afterward it becomes constant.
There are some advantages of Zener diode like voltage regulation, over voltage protection, switching power, reference element and fast response, etc.
There are some disadvantages. It cannot be used for high power